Welcome to Tech Bytes. Now, you know how a lot of network monitoring tools allow you to say, it's not the network. That's fine as far as that goes, but it doesn't change the fact that there is a problem that needs to be solved. So, a more useful tool would not only tell you that it's not the network, but also what the problem actually is. That tool would be integrated up and down the stack so you know what's going on quickly and can move past troubleshooting and into resolution. Our guest is Brandon Hale, CTO at IBM SevOne. We're going to get an overview of the SevOne network observability tool and explain how it helps get to the root of a performance problem by focusing on all the layers an application operates at. Brandon, welcome to Tech Bytes. Hey man, give us the elevator pitch. I don't think you guys have been on our network before, so we haven't heard from you. Give us that elevator pitch of what SevOne is and does.
Yeah, thanks for having us and thanks for that great setup because folks who have been in network engineering know when you're getting those trouble tickets, you're getting those frustrated users out at the branches and trying to use applications. They really don't care about line cards and packet drops and stuff like that, right? They're going to be like, when is Zoom going to be working again, dude? When when can I use the back office applications again? Things have been slow. Things have been, I've been getting errors. So we really focus on what we call application aware network performance because we know like the job that we're actually trying to do is deliver the app, not trying to deliver, routers and switches and things. That's the how. So we've done that across a couple pillars. What we see as the pillars of observability for your audience in particular is around the metrics that comes from the network devices, the flows that we can kind of observe applications running over those wires and over those devices, and then what we call synthetics or tests, which is like, hey, if a user wasn't actively using Zoom in Chicago right now, but that was a key part of my business. We just want to observe that all the time. We don't want to wait for a user to call us. We want to proactively, synthetically test that stuff. So that's how we view the three pillars of application aware network performance.
Okay, that's a helpful overview and provides some context. Can we get a little bit into the architecture? Like our audience is going to want to know, how am I getting this
Yeah.
telemetry? Where is it going? How is it analyzed?
Yeah, sure. So like a really big well, we have this joke website, guys. If you want to go to snmpdeadyet.com, that's the website that we run just for fun, and we really enjoy it. But we have had these conversations for years to be like, oh, it's going to be streaming telemetry, it's going to be Prometheus, it's going to be this, it's going to be that, and it's going to all change. But what we found to be the constant and something that works really well in all the environments we've ever been in is good old SNMP. So it's not dead yet, and that'll actually take you to our website eventually. But we do support all those other things, right? Like we're not stuck in the past. We're just saying like, hey, use what works, and if what
Mhm.
works changes, like we've done things with Prometheus, we've done a lot of things with streaming telemetry, but SNMP is the best. And you use the word architecture, so I wanted to follow that up with a comment about why SevOne is a little bit different from other products because we're designed for the biggest environments in the world, some of your biggest telecoms, some of your biggest investment banks. If you've traded stocks, you've booked airline tickets, flown on an airline, like all those networks are kind of the people who are using SevOne, and it's because of the ability to scale out the platform.
Mhm.
A lot of systems they might have a SQL database, maybe Microsoft, maybe Oracle, where all the data has to be kind of sent to.
Mhm.
We have a peer-to-peer architecture where every server is adding additional capacity. It runs the web services, it runs the database, it runs the APIs. Everything is included in this unit of compute, if that makes sense. And you can keep scaling up and up your ability to run the platform without being a DBA or having to figure out how to build a bigger, SQL server.
So SevOne is shipping me a box loaded with compute, and I'm pointing all of my telemetry, my SNMP, my flows to that.
Yeah, you could think about it as a box. We stopped shipping a physical box a while ago due to the move to virtualization and now containers. So people might be running on OpenShift, they might be running on VMware, things of that nature. But you could think about it as just another unit of compute joining the Sub1 cluster.
Okay, but that sits on my network. This unit of compute that I'm deploying in some
Yeah,
manner.
that's right. Yep.
Okay.
I like the way you said the move to virtualization because it just happened yesterday. We're just getting our heads around
We're still catching up, but now Broadcom's really punishing us for the whole thing. We're really
it.
rethinking the decision, right?
So Brandon, back in the day, I used to run some APM tools, application performance monitoring, and the architecture there, or not the architecture, but the design of it to build it, you would have all these different features and functions of the network or of the application, different things you were monitoring, and then you'd build like this dependency tree and kind of create this stack so that the application performance monitoring tool could give you root cause analysis and these kind of things. Is
Sure.
that kind of the right mindset with SevOne?
We're trying to be helpful in that we don't want you to spend a lot of time setting things up, right? Like we want you to get right to the value and right to kind of answering those performance questions you have. So one thing we did in the past couple releases was to bring in a database of all SaaS applications, not literally all, but like thousands of them. And so instead of going and identifying these are applications on the internet that my customer uses, or sorry, my users within the company use, we've already pre-identified everything from Netflix to Zoom to Office to, ChatGPT. All that stuff is going to be automatically identified for you in SevOne. And we have a really cool blog post about this where we show it all kind of looked like soup before, right, Ethan? Like you'd see a bunch of IP addresses. If you want to look them up, they might belong to an Amazon, block. Be like, yeah, of course, everything Slack runs on Amazon and everything Microsoft runs on Azure, but like that doesn't tell me what the application is. So we've done all the fingerprinting and identification for you.
Mm-hmm.
Obviously, there's going to be some degree of your own applications, like homegrown. We can resolve those either by DNS, like they might have a DNS name, it'll automatically pick that up. And then our partner Instana, another IBM product, has a
Yeah.
tremendous amount of depth in getting into the APM and actually tracing the applications and stitching together the different services that make up one macro service, micro into macro, if you will. But SevOne is really trying to be the network lens primarily, or the majority of the time, we want to automatically identify what the apps on the network are.
So but the different data you've gathered around flows, the things you know about SaaS applications, the fact that you've got that knowledge based on domain name metadata
Mhm.
means that you can reflect back to being not just here's a flow and here's some performance stuff, but here's the application that is indicated by this metadata and the impact to the application based what we're seeing through the network performance lens is X.
Yeah, here's an example of why this has been really useful. I didn't have this feature, but when I was a network engineer, a common problem would be the users at a branch, right? They're all kind of competing for an amount of bandwidth, right? Like maybe they had an MPLS line, maybe they use the internet and some sort of SD-WAN type of solution over the top of that to try to make it more reliable. But you never really had enough bandwidth for everybody, right? So you'd start to apply QoS and you start to try to trade off, like, okay, this application is going to be prioritized. But there's always contention for bandwidth, right? So when you come to SevOne and say, hey, I see the alert that's telling me the interface on that router is all utilized, it's full. That's great, but like why? And so our capability to drill down on that says, hey, based on the flow data and my ability to identify and fingerprint all those applications, somebody's doing a lot of Netflix, dude. Or
Mhm.
it could be anything. Like I've seen printers, I've seen print jobs going across the internet where when they shouldn't be. I've seen all kinds of things, but just that ability to within a couple of clicks identify it and say either I need to change a QoS policy or I need to do something different with that traffic or that user behavior. That really gets down to the bottom of solving those congestion issues.
So how would I, as a network engineer, interact with the data that you're gathering? I assume there's probably some kind of GUI and dashboards. Are there other ways for me to like run queries or do searches or drill down into more information?
Yeah, sure. I mean, often our users will start from a knock point of view, and we work with them to build policies that explain, is my network healthy or not healthy, right? Like I don't want to be chasing things that are all green. right? So a lot of our users will set up some dynamic alert policies. We baseline the performance of the network for every single indicator we collect. Doesn't matter what it is, automatically baselined, and that's like a seasonality thing. So if Monday at 10 a.m. is a really busy time in your environment, we start to pick up those trends, and we can say, hey, like we knew that was a busy time. We're not going to send you an alert because that was normal usage. But if we're seeing those high spikes at a time where we don't normally see them, that could drive an alert, that could drive an investigation by the NOC, and they might pass that ticket off with a little bit of exploration in the product to say we've built a report in SevOne that explains there was a congestion issue at the site. It affected application performance. These different applications is what the users complained about. And the root cause was, hey, there was some traffic maybe shouldn't have been prioritized and was, or traffic vice versa, right? And all that stuff would show up in our flow analysis.
Now, those actions that you were describing mostly were related to alerting and so on. Are there other actions that could be taken? Like, I want to kick off an automation workflow. I want to trigger another tool, these kind of things?
Yeah, sure. Within the SevOne space, the easiest way to do that is a webhook. And so if you have an alert policy, like, yeah, sure, we can set up an email or something, but the webhooks can really, it's almost like a choose your own adventure, right? Like you can come into a low code product. We have one called Concert Workflows. You've probably seen plenty of things like IFTTT and
Oh,
there's
yeah.
Node-RED and like there's so many cool things you could do with once I have the trigger coming out of SevOne's detected something. There's really no limit to what you could do with automation.
Is there an API into SevOne so I can pull data out of it?
Yeah, there's two ways to get data out of it. You can use the API to integrate with other systems, and maybe even your automation needs to come back for more information, but we can also push data to you. So we support Kafka, Apache Kafka or Apache Pulsar as a message bus and just say, as we collect data, you might have a larger strategy around data lakes and data
Yeah.
analytics that is bringing in multiple sources of data. I want the network data and the application data and maybe customer support data all coming together for part of a larger data lake strategy. And so we support pushing in real time to those types of systems.
You just reinforced your ability to scale. Like you mentioned near the top of the podcast, the
Yeah.
how large you can go, the kind of environment you support. Then you dropped Apache Kafka, and I was like, oh right, this solution goes really big.
It goes really big. Some of our telecom users are just really pushing in the millions of different objects detected and billions of data points a day and petabytes of stuff on the disk. It's pretty significant the size of these clusters.
What about cloud visibility? Because public cloud and SaaS applications are now part of that application
Yeah.
stack.
Yeah.
Can you get me visibility there?
We can, and we joked about, hey, like VMware happened yesterday, but we're really mature there. Like we're all in on VMs, but we're really kind of coming to a place of maturity, I think, on the adoption of cloud and putting more of our kind of primary workloads on cloud now. Even if you're like one of the kind of like more blue chip, type of enterprises,
We
and
meaning the industry
we
is,
meaning the industry, right? Like we
yeah.
work with a lot of large financial companies who would be more slower to move for like good reasons. It's like a lot of our financial transactions still run on mainframes,
Mhm.
right? IBM loves the mainframe, but like it's not just a punchline, right? Like it's really powering a lot of these banking and these like stock transactional things.
Mhm.
And those folks were probably some of the last to say, yeah, I'd put a primary workload on a public cloud versus my own cloud, my own mainframe, my own data center, right? But as we're doing that and we're seeing that start to become it's reaching this mature place now, and there's a lot of options on how to interconnect clouds to your own data center and interconnect different clouds to each other,
Mhm.
right? So in the Amazon world, right, like each slice of an application you develop might be in its own VPC. How do they talk to each other? You need a VPC gateway, essentially a router in the cloud. You don't manage it, but SevOne can get those observability metrics and those observability flows from Amazon's APIs. And our team has done some really interesting stuff to help you do that with performance and cost are kind of trade-offs there. If
Mhm.
you call the CloudWatch API, they're charging you like pennies per transaction, like everything's metered in Amazon. And we
Mhm.
found ways to do that again back to our need to achieve this huge amount of scalability. The way that that's working architecturally is Amazon publishes all the data to an S3 bucket. We get a notification, we can pick it up. And the reason why that's important for customers who might be on the large side is they don't have to do all those kind of individual API calls to get all the metrics out. They're coming in bulk, and that's both more cost efficient and kind of it's just more efficient all around. They're getting the metrics they need without all the back and forth.
So there's metrics being generated by like a transit gateway. Amazon is putting them in an S3 bucket as part of its regular dealings, and then SevOne can make API calls to that S3 bucket as opposed to the transit gateway to save cost.
Yeah, we wouldn't ever talk to the transit gateway directly. And
Okay.
they're almost like Amazon's almost like magical. Like maybe there isn't even a transit gateway. It's like it might be like 1,000 servers doing that stuff. We don't
Mhm.
really know how it works.
Right.
But it exposes metrics through an API they call CloudWatch, right? And that would be both time expensive and money expensive to continually pull that stuff. So we've come up with a solution with Amazon where they push the metrics to us and we can pull them all your transit gateways, all your EC2 instances, all your S3 buckets. Where we're a little bit different from Datadog's an awesome product, right? Like they would say, yeah, we also have cloud visibility. We've really focused on the networking side of it. Of course, we can observe a S3 bucket or an EC2 instance, but when it's like direct connections from data centers to the cloud, when it's NAC gateways and VPC gateways and load balancers, those are the things we think our users and your listeners are kind of the most responsible for and the most interested in. So we focused on being really deep on those technologies, and that's a piece of observability that, other classic NPM tools might be lacking, but the Datadogs and the APM people may also not be the same level of depth in. So that's the space we decided to focus our energies.
Brandon, I'm at KubeCon this week, and so Kubernetes is kind of top of mind for me. Do you
Yeah.
guys do anything special with Kubernetes environments?
We do something I think is really special with Kubernetes environments, and it uses a eBPF sensor that came out of Red Hat as an open source project. It's now part of OpenShift, but anybody running Kubernetes can run this same code. It's called NetObserve, right? And where that ties into network observability and SevOne is think about that virtual overlay network in Kubernetes. If you're a senior network engineer and you've been doing this for a long time, you're probably used to opening up a packet capture and kind of understanding what you're seeing across your network. Now there's like packets inside of packets, man, like everything shoved inside of VXLAN. And we don't really
Yeah.
know who's talking to who. It's
Uh-huh.
just a bunch of traffic going between Kubernetes nodes. And in order to decode that, you'd have to get really deep into strip off the VXLAN layer but
Yeah.
like then you have an IP address, right? That IP address is coming from like almost like a DHCP server. I don't know if it is technically, but these are dynamic IP addresses on pods that might be coming and going and getting rescheduled to different nodes as your OpenShift cluster is your Kubernetes cluster is doing its thing, right? Uh, what makes this solution really amazing is we're creating these flow records, think NetFlow, right? That tag everything at the source, right? So we're observing it using BPF as the technology of seeing those conversations, intercepting those conversations. You don't need any packet capture devices. You don't need taps and spans and all that type of junk. You just deploy this one operator. It makes sure that this agent runs on every node and it's rolling up all the conversations in your cluster, but they're already kind of spelled out for you. Back to this idea, we automatically identify all the SaaS applications that are going out to your internet. Same thing in the Kubernetes space, the pod namespace, the destination, who's talking to who, how much are they talking, and then what I think is the coolest field here that we were able to get is measuring round trip times. So it's like, hey, on a per pod to pod basis, round trip times are in the flows. You know exactly who's talking to who, but how long did it take is
Mhm.
measured as we're in the OSI model right now, guys. This is for the real hardcore network engineer. But the time between a SYN and an ACK, when I'm setting up my handshake,
Mhm.
we can take that delta, we can store that and say, all right, this is the network time. And what we're doing with that now, Ethan, is pairing that with what Instana knows and what APM products know is say, hey, what's the difference between the network transaction time and like that layer 7 transaction time? Back to the beginning of this conversation, is it the app or is it the network? I really want to
Mhm.
know. I really want to solve the real problem here. And that's kind of our next piece of work is to automatically line up those two pieces of data coming out of one Kubernetes environment.
Yeah, my brain is just like yes because uh, the magic here is you can tell me then with that information, especially with what's coming from Instana and being added to the mix.
Mhm.
It's a worker node that's got a CPU must be overloaded or it's having some kind of a hardware problem or something. You can begin to get into the nuts and bolts of what's happening in the cluster and infer
Yeah.
what's actually going on down there. Or it's just a pod. It's just a container running on the node that's got an issue because everybody else is having, but this one is broken for some reason. You can actually surface all of that information.
You totally can. And it's really interesting to me to watch all the things that happen in a Kubernetes cluster that I didn't know were happening. Like it's talking to the core DNS service and it's talking to this guy called the operator lifecycle manager. And I'm like, I didn't even know all this stuff was happening, man. But when you really need to understand why something's driving the CPU wild, you're like, well, who's consuming it? Right? It's no longer necessarily end users coming in the front door. It might be pods talking to other pods. It's all microservice oriented. And I don't necessarily know where this traffic's coming from until I can really kind of get inside and look
Mhm.
into the Kubernetes view of the world.
Are you able to tie IP addresses or flows to specific applications or pieces of applications in a microservice environment to actually help folks track down where the problem is? I'm thinking because
Yeah.
this is such an ephemeral environment, that kind of information could be hard to get.
Yeah, so the different fields there, we do record the IP as the source and the destination IP like any other NetFlow collector, but it's already being tagged with the namespace and the pod name. So
Okay.
you could say, hey, I want to see MySQL. Like we have some really powerful filters that we could do queries on top of this stuff and say, hey, show me all the pods talking to MySQL. Show me all the namespaces that come into this namespace. Talk to this guy's MySQL server, this guy's Postgres server. So it's really powerful once you have all those tags there.
Well, Brandon, we've crammed a 15-minute conversation into about 2025. So we got to call this at this point. But man, we got to get you
Okay.
back and have a longer conversation because the more you talk about different capabilities and use cases, the more intriguing SevOne is becoming for me. So hey, for folks that have listened to this and maybe they're intrigued as well, where would you send them to find more information?
Yeah, well, actually, I'm probably going to get in trouble for this website, but is snmpdeadyet.com. You will take you directly there. But
There'll be a link in the show notes to find SevOne. Of course, SevOne, SEVONE. You can just
yeah,
do a search for that, IBM SevOne, and of course that's gonna. We all know how search works. We're really good at it in 2025, and you can find a whole lot of different resources about that. And of course, is SNMP Dead Yet is another great site. Now, sponsors ensure that the packet pushers can continue to offer high quality, deeply technical content for your professional development. And guys, we give it all to you guys for free. That includes a dozen technical podcasts for your professional development on networking, security, IPv6, DevOps, and more. We have an industry blog. We got 2 weekly newsletters. There's a community Slack group. There's a YouTube channel. There's an IRC group. There's an IRC group. Yeah, that is still kicking around. That's still a thing. You can find all of those resources at packetpushers.net. And again, it is all free for you, no login required. And you can hear us on Spotify. You can thought lead with us on LinkedIn. Drew and I like doing the thought leadership thing. And then you can rate us on Apple Podcasts. Last but not least, remember that too much networking would never be enough.